Hello students, welcome to my channel Engineers Academy. In this video we are going to solve these two problems, and these two problems are interrelated to each other. So in the first problem it is said that the 150-pound man lies against the cushion for which the coefficient of static friction is 0.5. Determine the resultant normal and frictional forces the cushion exerts on him if it's due to rotation about the z-axis. He has a constant speed of 20 feet per second. Neglect the size of the man and take theta equals to 60 degree. So first of all I will find the generalized equation, and then for both of these problems, and then we will put the given data one by one and we will find the solution of both of these problems. So as we can see that this man along with the cushion is revolving around the z-axis. So if we consider the path like this, so the man is rotating about the z-axis in this circular path, and the radius of this circular path is 8 feet. So if we define our axes, so our normal axis will be acting towards the center of this circle. So this will be our normal axis, and the tangential axis will be since it is rotating like this, so it will be into the screen, and the binormal axis will be perpendicular or parallel to the z-axis. So this will be our binormal axis. So the weight of the man will be acting vertically downward, so we can draw that weight. So that weight will be acting in the negative b direction like this, and this weight is given, which is 150 pounds, and the friction force will be acting in the upward direction. If he is going to slip downwards, then the friction force will prevent him, right? So the friction force will be acting in the upward direction like this. So this will be the friction force. Let's say that friction force is F, and this friction force will be parallel to this cushion surface, so it will be making that same angle theta. And similarly the normal force will be applied by the cushion on the man, so that normal force will be perpendicular to this cushion. So this is that normal force. Now let me remove this circular path. So this is that force, this is that normal. So we are required to find this friction force and this normal force when this man is revolving about the z-axis with a velocity of 20 feet per second. So now if I extend that binormal axis, so as we can see that this binormal axis is perpendicular with this horizontal line, and this normal is perpendicular with this cushion or with this surface. So this means that the angle between the normal and the binormal axis is also that same angle theta which is given. So this is that theta. So we can resolve this normal force into its components. So it will have two components. One of the components will be this one, and it will have one component which will be acting in this direction. So if this is theta, then this angle is also theta, and this is the cos component. So we can say that this component, this is n cos of theta, and this is n sin of theta. And similarly this force F is making theta angle here, so it will be making that same angle theta here as well. So again we can resolve this friction force into its components. It will have one component which will be acting in this direction, and this one will be the cos component. So we can say that this is F cos of theta, and similarly it will have one component which will be acting in the positive b direction. So this is F sin of theta. So now if we apply the summation of forces along the binormal axis, so that will be equal to 0, since there is no motion along the binormal axis. The motion is in the tangential direction, right? So there is no acceleration in the binormal axis, along the binormal axis. So if I add up, so as we can see that along the binormal axis we have this n cos of theta which is acting in the positive b direction. So I will write n cos of theta plus this F sin of theta, and minus the weight, and weight is 150 pounds. So this is equal to 0. If I bring this weight to the other side, so it will become positive, so we will have this equation, n cos of theta plus f sin theta equals to 150. Let's say this is equation 1. Now if we apply the summation of forces along the normal axis, so this will be equal to m times an, and again as we can see that this n sine of theta is acting in the positive n direction, so I will write n sine of theta minus this f cos of theta. This will be equal to mass, so the weight is 150, so 150 divided by g, so g value in these units is 32.2 feet per second square, and into an. So an is v square divided by rho, that is the radius of the curvature. So again we are given the velocity which is 20 feet per second, so I can put v equals to 20, so this will be 20 square, and let's say that we find the generalized equation. So this is v square, since we will be using these two equations for the second problem as well. So this is v square, and the radius remains the constant, so that is 8 feet. So this is 8. So we can simplify this. This is 150 divided by 32.2. 150 divided by 32.2 multiply by 8. So this is 0.582. So 0.582 v square. 0.582 v square. This is equation 2. Now for the first problem, to solve this problem, we are given that v equals to 20 feet per second and theta equals to 60 degrees. So now we can put both of these values in these two equations. So since we are using this theta, so cos of 60, we can find cos of 60. So cos of 60 is 0.5, and sine of 60 is 0.866. Sine of 60 is 0.866. So this is 0.866. So now if I put all these in equation 1, so we can say that this is n cos of theta, and cos of theta is 0.5, so we can say that this will be 0.5 n plus sine of theta is 0.866, so this will become 0.866 f equals to 150. So now this is the modified equation 1 for this problem 1371. Now the second equation, this is n sine of theta, again sine of theta is 0.866, so this will become 0.866 n minus cos of 60 is 0.5, so this will become minus 0.5 f, and this will be equal to 0.582, and the velocity is given which is 20, so 0.582, 0.582 multiplied by 20 square. So this is 232.8. 232.8. So this is equation 2 for the first problem. Now we need to eliminate one of the variables, since we have two equations and two unknowns. So if we want to find this force F, so we have to eliminate this. So if I divide equation 1 by 0.5, so if we divide equation 1 by 0.5, so this will become 1, 0.5 divided by 0.5, so this will become 1n, and 0.866 divided by 0.5, 0.866 divided by 0.5, this gives me 1.732, so this is 1.732 f, and 150 divided by 0.5, so it will become 300. 150 divided by 0.5, this is 300. This is 300. Now we need to divide this whole equation by 0.866, so we will have n then 0.5 divided by 0.866, this is 0.577, 0.577, and 232.8 divided by 0.866, this is 268.82. 268.82. Now this is equation 2. So now if I subtract equation 2 from 1, so this will become negative, this will become positive, and this will become negative. So this will be cancelled out. So this is 1.732 plus 1.732 plus 0.577, 2.309 F, and 300 minus 268.82. This is 31.18, 31.18, and if I divide both sides of equation by 2.309, so we will get that F value for the first problem. So this answer divided by 2.309. So the friction force is 13.50 pounds. Now to find this normal N force, we can put this F value in equation 1. So from equation 1 we can write that N is equal to 300 minus this 1.732 F, and F value is 13.50. So 300 minus 1.732 into 13.50. So N is 276.62, 276.62 pounds. Now in the second problem, these two same equations are used, but there is only one difference. And the problem statement says that we need to determine the smallest angle theta of the cushion at which he will begin to slip off. So if he begins to slip off from this cushion in the upward direction, if he is going to move in the upward direction, then the friction force will be acting in the downward direction like this. So in the first case, the friction force was trying to keep the body attached with the cushion, right? So that friction force was acting in the upward direction. But since the body is now going off the cushion, so the friction force will again keep the body on the cushion, right? So the friction force will be acting downward for the second case. So if this is the case, then we need to reverse this sign for the wherever the F is involved, right? So this sign will become negative and this sign will become positive, right? So now we are given the velocity and the friction force is 0.5 N. So if I put F equals to 0.5 N in this equation, so we will have equation 1 like this. So this is N cos of theta minus 0.5 N sine of theta, and this is equal to 150. And now if I take N common from these two terms, so this will be N cos of theta minus 0.5 sine of theta, and this is equal to 150. Or we can say that N is equal to 150 divided by cos of theta minus 0.5 sine of theta. And now again, if I replace this F by 0.5 N in this equation 2, so we will have equation 2 like this. So this will be N sine of theta plus 0.5 N cos of theta equals to 0.582 v square, and for the second case v square is velocity is 30 feet, so we can put that 30 square. And now if I take N common from both of these terms, so we will have sine of theta plus 0.5 cos of theta And now we can replace this n by this value or this equation, right? So we can write that this is 150 divided by cos of theta minus 0.5 sine of theta into sine of theta plus 0.5 cos of theta, and this will be equal to 0.0582 into 30 square, 523.8. So this is 523.8. Now if I divide both sides of the equation by, or if I multiply both sides of the equation with cos of theta minus 0.5 sine theta, so we will be left with 150 sine of theta plus 0.5 cos of theta, and this will be equal to 523.8 cos of theta minus 0.5 sine of theta. So now we can simplify this. This will become 150 sine of theta, and 150 into 0.5 will become 75 cos of theta, and this will be 523.8 cos of theta, and this is 523.8 into 0.5, so this is 261.9 sine of theta. And now if I bring this sine component to this side, this is 150 sine terms to this side on the left hand side, so this will become plus 261.9 sine of theta, and 523.8 cos of theta minus this term on the other side, so this will become minus 75 cos of theta. So we can add both of these, so this will be 150 plus 261.9, so this gives me 411.9 sine of theta, and this is equal to 523.8 minus 75, this is 448.8 cos of theta, and if we divide both sides by cos of theta, so this will become tan theta. So we can say that 411.9 tan theta equal to 448.8, and if I divide both sides by 411.9, so we will this ratio will be equal to tan theta, and if I take tan inverse, so we will get theta we will get that required theta. So this is tan inverse 448.8 divided by 411.9. So this gives us theta equals to 47.45. So theta equals to 47.45 degrees for the second case. So this is that smallest angle theta for which the man will begin to slip off the cushion. So this is the solution of these two problems. I hope you people would have understood the solution method for these two problems. Kindly subscribe my channel if you haven't subscribed it yet. Also like these videos if you people want me to solve such more problems from engineering dynamics.